So up to this point, we have been using the notation from what we call differentials as just a notation that we've taken the derivative. But at this point, what we are now going to do is really separate the two, because the differential actually has a meaning. So here, as stated, we've been using this as a single entity, okay, when we're taking the derivative of y with respect to x. So we just have dy dx. But these symbols have had no meaning up to this point. So what we will do is define them as the way they should be treated. So if you think about it, when we first started calculus, we talked about the slope. So there were multiple notations for the slope. One of them, which was dy over dx, which indicates the change in y over the change in x. And on a graph, those can be independent from one another. So in order to make them independent, and we're assuming that f is a differentiable function at a given x value, we will define dx to be an independent variable that can have a real value defined by the formula dy is equal to f prime of x dx. Okay, but what does this mean in plain English? So here, when you take the derivative, meaning this is y is equal to some function, you indicate dy dx is the derivative, and then you would take the derivative of the function. To separate the two entities, you multiply each side by dx, and then you end up with this. So then you have the slope of the tangent line, which is here, okay? And you can look at these separately, as dy represents the change in your y value, as dx represents delta x, or the change in x. So what we can do is actually find what's called a differential. So if you are given instruction to find a differential, that's what we want to do. We want to solve for dy in terms of dx. So here I have a problem that says find the differential. So what this means is that you take the derivative. So you have dy dx is equal to 3x squared. To find the differential, which is dy, you multiply by dx. So dy is equal to 3x squared dx. And what we can actually do is use this to solve.